Hello guys, today I'm going to show how you can create a binary search tree in C++. So this is an online ID I'm using. Let us delete the previous code. We'll start from scratch. So let's first include IO stream that will help us input and output. Then I'm going to define that I'm using namespace std so that I don't have to do it again and again. Okay, now we're going to define the node, or before that let's just write the main function so that we know where what is. Okay, now we're going to make the node class. In this we'll have some public parameters like node, which will be a pointer left, then int value, then node, you guessed it right, it is right. Okay, now here the structure will be something like this. I'll have a method to add node. I'll put the values here like this. May put a few more. Let's give a 5 here. Let's give a 7 here, and I'll give a 9. Okay, now here what is happening is we'll call a function here. Let's just define the function then. The function has no return type, so it is void. It will have an integer called value. We'll also have to define it here, because in C++ we have to define it before calling, like this. Okay, it is fine now. Now let us perform the check. If value, okay, before that let us define the head node, which will be null initially. Also these two will be null, I forgot that, so that there is no confusion whether value exists or not. So here first of all we will check if head is equal to null. If it is null, we are going to create a new node for head. Now once the node is created, we will have to assign a value. The value will be taken from the input parameter. Now what happens if the node is not null? Now here we are going to, can I increase the size a bit? Okay, that is fine. I'll pull it up. Now here if the node head is not null, then what we'll do is use a function to crawl to the last node where we need to add the new node. Okay, so which I'll call it docker node. You can name it anything. So I'll have a function called find docker node. Okay, here I'll pass the value so that it knows which value, which way it should crawl according to the value. Now once I get the docker node, I will again check if the value is greater than docker node dot value. One more thing, we have to check if it is equal to also, otherwise equal to will be a corner case which will not be handled. Okay, so once we do that, if the value is greater than docker node dot value, then in the docker node right we will create a new node, because we are keeping all the greater values to the right. So we have a node created here. Now we have to assign the value to this right node as well. Value will be same value taken from the parameter. If it is else, that is the value is less than the docker node value, then it will be kept on the left side. We write that again, left, new node docker node left, then value is equal to the value again. Okay, I think this is done. Let us create the function for finding docker node. It will have a return type of pointer, integer value, let me define it here also, otherwise I'll forget. Find Docker node of integer type. That's it. Okay, now the role of Docker node is to crawl. So while crawling, we don't want to damage the head node or change the head node. We'll make a temporary node, t node, which will be initially equal to the head node. Now the idea is to similarly crawl if value is greater than or equal to t node dot value. T node is equal to t node dot right. If it's greater, it will take the right path. Is it recording? Yeah. Okay, if it is not greater, then it will take equal to t node dot left one. Okay, that way it will continue to crawl. But what if the right node is null? We cannot assign that, right? In that case, we'll also know that we found the last node or end node. Then what we can do is we can check if t node dot right is equal to null, then we will return t node. Again, here also we can check if t node dot left is equal to null, then here also we should return the t node. Okay, that is for the find Docker node. Everything is done. Let me find some, if any issues there, you need a semicolon here for defining. Also, to visualize it more properly, we will use some output. See out add node to know which number is being added. I'll have value here and a slash n, so it goes to the new line and keeps it clean. Okay, so here I made a mistake. This will only check for one time. For continuous, we need a while loop, and I don't know how long it should run, so I'll keep it as true. Then paste the logic inside it. It is a little messed up. I'll try to tab. See. Okay, now it's fine. Okay, but here also I want to see which node is being crawled through. Okay, so I'll have another cout. Give a few dashes to differentiate between add node and this through. It will be t node dot value, and a slash n to keep it clean. So I think this is done. Hopefully it will run in the first try. Let us check. Okay, great, it ran on the first try. So I'll tell you what is happening here. This first one is add node. In this case, the head is null. So if the head is null, it is just assigning a value to the head and it doesn't need to crawl through anything. In the second case, when adding 3, it will first go through head, which is 2, using this Docker node to find the last one. So it will go through 2. Again, while adding 5, it will go through the previously added values 2 and 3. While adding 7, it will go to the other 3, and similarly while adding 9, it will go to the all other previous values. Now of course there are variations to how the input can be. If I change, like instead of giving higher one every time, if I give lower one, then it will not go through the lower values. So that variation you can understand. I don't want to confuse you right now, but this is the simplified version of a BST, which you can implement more features and use it in different places and logics. Thank you very much for watching. I'll be back with a new video. Until then, goodbye.